Okay, happy Monday, everybody. Today we're going to start looking at getting some input. It says keyboard input in game loops. We're actually going to look at a couple other things besides just keyboard input today as well. But today we're going to get into the code we need to actually make an interactive game where we press keys, stuff happens on the display, and the game reacts to what we're doing, and we can see those things happen on the screen. All right, let's get started. All right, so quick review. We did comparisons previously, and we saw those comparison operators that are listed down there. Equal, not equal, less than, greater than, less than or equal to, greater than or equal to. And we use those inside of if statements to say, like, for example, if health less than or equal to 0, then game over. Or while I is less than 10, do something, and then I plus equal 1. And so we use the comparisons with both if statements and while loops. Well, one of the things that I want to talk about briefly is there's the capability of doing more complex comparisons. In other words, Python allows us to create these comparisons that are basically created by combining other comparisons in combination. And to do that, there are a few more operators that we're going to introduce today, and those are and, or, and not. And those are called logical operators. In other words, we could say, okay, what things can make the game be over? The game can end if you win, or the game could end if you die. So those are two possibilities. So if you think of a game like Candy Crush, what could be the end of the level? You either run out of moves, or you complete all the tasks and get all of the candies that you need or whatever you do in that game. So notice that, or also in your daily life, you make decisions based on this. So for example, and if it's Friday and I have enough money, I'm going to go to Kroger and buy a case of beer or whatever. So there's an and involved in that. Or if it's time to go to class and there's a quiz, then I'm going to take the quiz. So notice ands and ors and nots are kind of an intrinsic part of your decision-making process. And the cool thing is Python allows us to do that. So here's how they work. So the logical operators, and I have two other comparisons, and I put an and between them. That this is only true if this is true and this is true. So in other words, if both sides are true, then the and of those is true. Now with or, all that matters is that one side or, notice I'm using that in the English, or the other is true. So if this side is true or that's true, the whole result is true. And then not is the last one. Not here just inverts whatever it is. So not, if this was true, putting a not in front of it would make it true when this is false, and false when that's true. So in other words, it just flips true to false, false to true, it just inverts it. And you can use those together and make really complicated things like if this is true and this is true, and this is true, or this is true, then the whole thing is true. So you can make groups of those. Or you could say if not this and this. You can use those in a lot of different ways. All right, so looking at a few examples here, and you can try these in the shell if you want to yourself and see what happens, but here I've created a variable x and put 10 in it. I've created a variable y and put 20 in it. And I created a variable z and put 30 in it. Now, x less than y, so is x less than y? Is 10 less than 20? Yes, so this part's true. And then the other side over here, y less than z, yes, 20 is definitely less than 30. So this is true. So with an and, if that's true and that's true, the whole result is true, so this one's going to be true. All right, the next one, if x equal 10 and z equal x plus y, so again, x equal 10, we know that that's true. And is z equal to x plus y? Well, x is 10, y is 20, so 10 plus 20 is 30, so 30 is definitely equal to 30, so that's true. So again, true and true produces true. Now, the next one, x equal 100, that's false, and z equal 30, well, that's true. So we have a false and a true, but remember with an and, they both have to be true, and in this case, this x equal 100 is false, so the whole thing becomes false. And then the last one is the same as the one before, but I just changed the and to an or. X equal 100, that's false, or is z equal 30, that's true, so false or true. Only one of them has to be true to make the whole thing true, so that one's true. And there are a lot of ways you could combine these to do different things in your game. So for example, if health is less than or equal to 0, and the time has run out. If time left is less than or equal to 0, then game over. So if you ran out of time or you died, the game ends. Or you might have, if the health is greater than or equal to 0 and they completed the level, they got to the final goal, whatever, then we might want to say you finished the level. So it's all kinds of uses for these. All right, so now that we covered that, let's move on to kind of the meat of today's lecture, and that's this Pygame keyboard input and other types of input. All right, so keyboard input comes into your game as an event that goes to the window of that game. And that's kind of an operating system mechanism in Windows, that you have a bunch of different windows open on your desktop. Well, when you type, how does it send the keys to one program, and then you click on another one and it sends it there? You click on a different tab and it sends them there. How does that all get sorted out when you have one keyboard that has to be shared across multiple programs? Well, Windows kind of handles that, and what it does is it uses this system called the event queue. And what events are, think of events as something like written on like a postcard or a Post-it note. So you write some message on that Post-it note, and then it goes to that gets stuck on that window for whichever window you were typing into at the time. So essentially what happens is an event that says there's a key down event with this key, and it's going to the Pygame window. And then if you switch to a browser, it says there's a key down event with this key that's going to the browser window. Now, so in other words, you think of like there's a mailbox there, and that mailbox just builds up a stack of those cards that come in. So as you're typing really rapidly, typing stuff into your program, it's just creating event after event after event, and it's kind of stacking them up in that queue. And that queue is implemented as a FIFO buffer, which stands for first in, first out, meaning that their order stays the same. The one you pressed first is the one the program will receive first. And it will kind of buffer those up, but it's up to your program to then read those events and then do something about them. In other words, somebody has to check the mail, get the postcards out of the box, and do something with them. And if you've ever had a program where it says, Windows says, it looks like this program has stopped responding, and I know everybody in here that's used Windows has gotten that. What do you want me to do? You want me to kill it, or you want me to wait? The way that Windows knows that a program has stopped responding is if the mailbox, that event queue, that FIFO, starts filling up and nobody's taking events out of there. So in other words, the Windows will say, hey, this mailbox is filling up and nobody's getting the mail. It looks like the person who lives here is dead. And so it'll basically say, there may be a problem with this program. Do you want to kill it? Because it looks like it's not processing, it's not getting its mail, it's not processing those events. Now, that would happen to us if we didn't do anything with those events that came into our Pygame window. But fortunately, Pygame gives us tools that help us read those events and process those events in a relatively easy way. So let's take a quick look. All right, the first thing is pygame.event.pump. What that does is says, hey, Pygame, go out and sort through the mail and pull in all the events that are there and process any of them inside of Pygame itself. And generally, the idea behind pygame.event.pump is you'd call that over and over again in your program. In other words, check the mail, draw some stuff on the screen, do some other things, and then go back and check the mail again. Because again, key presses are going to be coming into the program. Other events like the moving the window or resizing the window, those are also events. The mouse moving is an event. The mouse being clicked is an event. So all of those ways of interacting with that window are all events of some sort. Now, the second part of this is this pygame.key.getPressed function. What that does is it returns a state of all the keys. Now, a couple details quickly. We already mentioned this. The Pygame event pump function should be called within your game loop or something in your program that happens over and over again. And that's going to allow Pygame to keep track of the state of all the keys for us. Now, pygame.key.getPressed function, that returns a giant tuple. And if you remember what a tuple is, it's like multiple items stored together. We saw that with colors, where you had this parentheses and you had 255, well, let me do it this way, 255, 255, 255. That was a tuple that had 3 items in it, a red part, a green part, and a blue part. Or for you at home, red part, green part, blue part, going that way. So what happens when you call pygame.key.getPressed is it returns a giant tuple that has either a 1 or a 0 for every key on the keyboard, whether it's currently pressed or not. So in other words, it's returning the state of every key on the keyboard. 0 is not pressed, 1 is pressed. Now, fortunately for us, there's an easy way to tell which part of that giant thing goes with which key on the keyboard. And here's an example to illustrate that. So in other words, we call pygame.event.pump that tells Pygame to go get all the mail, get all the postcards and process them. And then we call pygame.key.getPressed, which returns that giant tuple, which we're storing in a variable. So inside of this keys variable is a giant tuple with some like 0, 0, 0, 0, 0, 1. That key is pressed, 0, 0, and so forth all the way across. So we have that, but now we want to look in there and see if a particular item in there is a 1 or a 0. Is it pressed or is it not pressed? So the way we do that is Pygame defines all these constants for us. So for example, pygame.k, capital K underscore capital escape means the escape key is currently pressed. So if the escape key is pressed in this keys tuple, then we would take some action based on that, make the game end. Or if the A key is pressed, then move the character left on the screen. If the D key is pressed, move the character right. Notice you can stack up as many of these if statements as well. You can say if keys square bracket pygame.k underscore space, all the word space right now, capitals, S-P-A-C-E, then make the character on the screen jump. And we're going to do stuff like that in the games we write in the future. But this is kind of the basis for that. So here's a full keyboard example that if you type this in, essentially what it does, it just gives us a display. And what it does is it's going to over and over again create random circles on the screen until we press escape. So notice what it does. We pump the event queue, pygame.event.pump. Keys equal pygame.key.getPressed. If keys pygame.k underscore escape, if that's true, that means the key is pressed. So we break, and remember what break does? That immediately jumps us out of this while loop. So we're in the while loop, we immediately jump out, and then we do pygame.display.quit, which closes the screen. So in other words, if I run this program, it's going to wildly create circles all over the place as fast as it can until we hit the escape key. And just to illustrate that, here, let me copy this code and then we'll try it. Oops, that is not what I want. So let's paste this into Python and then try it real quick. So I just highlighted that and did a Control C. Now let me do a Shift F5 to return back to the thing. All right, so let's switch over to Python here quickly. Let me switch so you can see what I'm doing. Make this a little smaller. And let me do File New. And you can't see the top of that, so I move that down. All right, there we go. Now I'm just going to paste our code in there. And I've got some alignment issues here from where I pasted that. All right, let's see if that works. So I'm just going to do run module. And I'm just going to call it keytest.py. And we have a problem. Oh, we have a misspelling. Let me fix that really quick. Pygame. Let's try again. I'll fix that on the slides too. All right, and there you'll notice it makes circles. It's making one circle every time through the loop as fast as it can. They're all white right now. We can make them random colors, but it's going to do that until I hit the escape key. So here's my finger. I'm about to hit the escape key now. As soon as I hit that, notice it saw that that key value changed. It hit the break jumped out of the loop. It caused it to end. So back to the program. There's what the program looks like. All right, let's go back to the slides. And let me fix that typo in here real quick. Pygame. Okay. All right, so there's our example code that's doing something with that key press. All right, now let's take a quick aside here to look at some mouse functions. All right, so looking at the mouse functions here, you'll notice looking at that, they're just a set of functions here that do something similar to what the keyboard functions did. So pygame.mouse.getPosition returns a tuple that has the x coordinate and the y coordinate in the window. So in other words, it's on the window itself. So if you had a window that was 800 by 600 and you got a thing that said 100 100, you'd be 100 over and 100 down is where the mouse is when we return that. And it's going to fill in these variables for us. Now we can also get the button status by pygame.mouse.getPressed, but it's got 3 buttons, the left button, middle button, and the right button. And these are just variable names over on the left that I put in there to help you see that. But MLB, mouse, left button, MB, mouse, middle button, MRB, mouse, right button. So we can tell which of those 3 is currently pressed or not. You can also hide the cursor, pygame.mouse.setVisible. You can put a true or false in here to hide it or show it. Put false, it goes away. If you put true, it shows up. And then pygame.mouse.setPosition. That lets us set the position of the mouse on the screen. When we call that, I would say you should never set the mouse position. That's a really irritating thing to do because the mouse is kind of like your finger. And if your finger just magically teleported somewhere else, it would be really disconcerting. And so I would suggest not doing that unless that's part of the gameplay where it says, hey, click on this thing, and you try to get to it and it moves the mouse away to be irritating on purpose. So you probably shouldn't be setting the mouse position very often. Maybe if you have some game where something is controlled by the mouse, like a puck, and you want to start it out in a certain position, like you have to, like an operation game, you want to move this thing through the maze without touching the side, or it'll go bzzz, then maybe you want to start it at a certain spot on the screen and then they can move it around from there. But for the most part, don't just randomly change the mouse position. All right, now a couple other functions that I want to mention here. Timing functions. There's this pygame.time.wait that's in milliseconds. That works a lot like sleep. And it's not particularly accurate, so for waiting for a long period of time, it's good. There's also pygame.time.delay, which is very accurate, which also takes milliseconds. And if you're not familiar with milliseconds, those are thousandths of a second. So for example, if you wanted to wait 100th of a second, you'd put 10. If you wanted to wait a half a second, you'd put 500. If you want to wait a whole second, you'd put 1,000 in there. All right, pygame.timer.getTicks tells us the number of milliseconds since Pygame was initialized. And that can be useful for timing things in your game. We'll see these again later. And then often in games, we want to maintain a constant frame rate. So I'm going to show you how to do that. And that is, before our game loop, we would create this clock object. This is just a variable name, equal pygame.time.clock. And then from there, inside of the loop, we would say FPS clock.tick, and we'd put a rate in here, like 60. And that would make it so that when it hits that, it'll delay if it needs to make the time always get to be 60 hertz, or 1/60th of a second before it goes on and then hits it again. So that can be useful to make a game that runs at a constant frame rate that will, no matter what's going on in the game, it'll always hit that, delay if it needs to, otherwise continue on, and you'll get like a 60 hertz frame rate. You can also call this getFPS function, which will return the current frames per second. And if you're going to be doing things in a loop, we'll also need to know how to clear the screen. So in other words, when you write a game, we need to draw some stuff, and then the next time in the loop, probably clear the screen and then draw the stuff somewhere else. And the next time for the loop, clear the screen, draw stuff somewhere else, over and over again. And that's kind of how we create animation. And so to clear the screen, there's 2 ways that I'm going to present here. The one that I like is ds.fill. You just pass it a color tuple, red, green, blue. This would clear the display surface to black. So ds is the display surface. You do a .fill and put the color you want. If you wanted to clear it to white, you just put 255, 255, 255. If you want to clear it to blue, put 0, 0, 255, whatever you do on your game. You can also clear the entire screen or just some sub portion of it by using a rectangle. And we already learned how to do rectangles last 2 lectures ago. So pygame.draw.rect onto the display surface, color of black, 0, 0, 800, 600. That's the whole screen the way that we created it in our examples. And then 0 makes it filled in. So usually the screen is cleared once for every iteration of the game loops. In other words, every time the loop runs, clear the screen. Next time through the loop, clear the screen. So in other words, we're going to have a game loop that's like clear the screen, draw stuff, update the screen. Loop back around, do things, clear the screen, draw stuff, update the screen. All right, which brings us to the concept of a game loop. And with game loops, you'll notice that every game has a game loop involved. So you think about a game like chess. What's the game loop look like? Well, you set up the board. So you get out the board, you put the pieces in their right positions, queen on her color, all of the pieces in the right places. And then after that, it's white's move. So then white makes a legal move. You check for checkmate, which can't really happen after one move, but you check for checkmate or checkmate. And then you announce it if it's check. If it's checkmate, it's game over. And then it's black's move. So black then looks at the board, makes a legal move, check for checkmate, goes back to white's turn. And it just alternates between black, white, well, white first, white, black, white, black, white, black, white, black. They just keep taking turns until the game is over. Now, what can make the game be over? Well, somebody's has checkmate. Could be a stalemate. Or it could be somebody resigns. So somebody says, no, I'm going to lose. I'm going to give up now rather than waste our time. Or they might resign for other reasons, like I think I might lose and I would feel sad about that. So it's easier to just give up than it is to lose. Think about basketball. Basketball, you start off with the tip-off. The clock starts. You continue playing until NBA, the first quarter is done, and then you start the clock again and do the second quarter, and then you have halftime, and then after halftime you come back and start the clock again for the third quarter, and then you start the clock again for the fourth quarter, and then time eventually runs out. And if it's a tie, then you have overtime. If it's not a tie, then whoever has more points wins. And so notice that there's a game loop involved there as well, though. Even inside of those quarters, like there's a possession, they score, the possession arrow goes the other way. They inbound the ball. If they score, the possession arrow goes the other way. And so there's a loop involved inside of that larger loop of quarter one, quarter two, quarter three, quarter four. Boxing, you start off with round one. There's a 5-minute timer for round one. When that expires, if the contest continues, then it goes on to round two and so forth until the final round. And depending on what kind of contest it is, that could be 3 or 5 or 10 or 12 rounds. Could be other numbers too. But how does that end? Well, somebody throws in the towel, somebody gets a KO or a TKO, or the rounds expire and it goes to the judges to scorecards. And then poker, the same thing. There's a game loop there of who's the dealer. If there is a dealer, then it's who has the button, and it goes around and they each take turns, and eventually a hand is done. And something like No Limit Hold'em continues until all of the money, or chips, let's say, all the chips are in one person's hand. So notice there's a game loop involved, though, with all of these. Now, video games also have game loops. And the game loops in video games, it's usually useful to think of those divided up into phases. So the first phase would be the pre-loop, or before the loop. And that's generally like the top of your program where modules get loaded, variables and things like that get initialized. Data gets loaded into the program into variables, assets like sounds or graphics, or in the case of 3D games, like levels with textures and models and things like that. All that stuff has to get loaded into memory. And so you can think of that pre-loop part as like, let's say you're playing an Xbox game and you say, okay, start this level. And then it usually has like a loading screen and maybe a little loading bar in it. Like you have to wait until it's ready. That's it loading up all the things it needs for the level that you're on. That's the pre-loop part of the game loop. Now, after everything is initialized and ready, we move on to the game loop part. And the game loop portion of that is where we're going to process events, meaning like pygame.event.pum, and then do something with those, read the input, decide if this key was pressed, then change this variable or whatever. Process that input so read the input would be getting the state of the keys, processing the input would be doing something about which keys are pressed, and then we update the game variables in the form of game state, like what's your health now, what's the position of you on the screen, what's the position of the enemies on the screen, how many points do you have, updating all that. So updating all the things about the game, particles that are flying around, explosions that are happening, sounds that are playing. But then we get to the rendering portion where we clear the screen, draw everything in its new state that it's in, and then update the display so you see the changes made. So in other words, that game loop part, and then that's the part you're going to repeat. So this is all going to be included inside of like a while loop, like while true. So over and over again, it's going to pump the events, read the keyboard, do something about what keys were pressed, update some variables based on that or other calculations, and then clear the screen, render the screen, update the screen, repeat, and do it over and over and over again. And that's how we're going to make our games. Now, the last part of this is obviously the post-loop portion, meaning that when the game is done or the level is done, we need to clean up stuff. We need to save, maybe save your progress in a save game file, maybe display some kind of exit message, free up any assets that were loaded, and then ultimately close the window, exit the program. So that's the idea behind a game loop. And let's do a quick example. So we're going to code up an example of this game loop. And I'm going to actually start off with that circle code that we already have up and just make some modifications. But we're going to make a single circle that we're going to move around on the screen using these keys on the keyboard. All right, so let's switch over and write the code for that. So I'm going to switch over to here. I'm going to do a save as of this. And I'm going to call it game loop 1. Okay, so we already have a screen popping up, but we don't want to just put random circles around here. So I'm going to go ahead and get rid of, first thing I'm going to do is I'm going to get rid of this line. Actually, those two lines. And I'm going to get rid of random because I'm not using it right now. I'm going to put a comment up here. Simple game loop example. Now, what I'm going to do though is if I'm going to have a player that moves around, I need to set its initial position. So here I'm going to say player, here I'll do underscore x equal, let's start it in the middle of the screen, 400. Player underscore y equal 300. So there are two variables I set up to keep track of where the player is on the screen. The player when they start is going to be at 400, 300, right in the middle of the screen. Now down in my code down here, I'm going to need to clear the screen. So ds.fill, and I'm going to use black, so 0, 0, 0. So there's clearing the screen. Now I'm going to want to draw the player in that position, so it's going to be a ds or a Pygame .draw .circle. If you remember how that works, we give it the surface, we give it the color. Let's just make it white. Let's make it not quite white. So 255, 255, 100, 255, 255 is kind of a yellow, so it's going to be kind of a lightish, washed out yellow, maybe like a beige. We'll see what color it is. We can change it if we want to later. Now we give it the center. Well, the center where I want the circle is going to be player x, comma, player y. And now we're going to give it a radius. And I'm just going to give it 10 for right now. Oh, and we also need to make it filled in. I'll just put a 0 for the width. All right, so now let's go and run this and see what we got. So there's my yellow circle in the middle of that screen, but I haven't made it so it moves around yet. But notice that it's constantly clearing the screen, redrawing the circle, clearing the screen, redrawing it, but we don't see it flickering because we're in charge of updating the display when we want it to, and we're only ever updating it when the circle's there. Now, and notice the escape got us out of that. So now we're ready to actually make that thing move. So to make it move, we want to use W, A, and S and D. So here, if keys, square bracket, pygame.k underscore, let's do A first, A. If that's pressed, then what do we want to do? And let me fix the indentation levels on this. This is kind of, pasting that in here kind of messed it up a little bit. There we go. All right, so in our case, what do we want to do when they press the letter A? So let's think about what happens. So A, we want to move left. So notice that we want to decrease the value of player X. So if that gets less, it'll move toward the left of the screen. So to do that, in our code, we'll come down here. Player X, how do we make that smaller? Well, let's just do a minus equal 1. So if they press A, or if A is being pressed, we subtract 1 from player X. Now let's go ahead and do D while we're at it too, since that's just going to be the opposite. So if and I just did a cut and paste there, so Pygame K underscore D. Notice that these are lowercase over here, unless you're using one of the constants like this, and then they're all uppercase. So this is going to be the same thing, but we're going to do plus equal 1. Now let's go and run that and see what happens. So there's our circle in the middle of the screen. Let me move it down so you can see more of that. And if I press A, it moves to the left. If I press D, it moves to the right. All right, now one thing that we want to do before we do anything else is I want to show you how to cap the frame rate, and I'm going to put it at 60 Hertz. So if you remember how we did that, we made this variable up here. And this was in the note, so you make this clock object thing. So this is like, hey, Pygame, give me one of your clocks. And then at the top of our loop, we're going to do right here, FPS clock. That's our variable we're holding the clock in, .tick. And we're going to give it the frame rate, and I'm going to put it at 60. Now when I add that, you'll notice when I run my program now when I press the key, it's much slower, but it's also much steadier. So if I want this to move faster than it is right now, how do I do that? Well, the easy way to do that is just to change this by more than 1 every time. So here, let's instead of move it let's do minus equal 5 and plus equal 5. And that becomes our speed now. All right, so that looks a little better. And you notice it's smoother. I don't know how it's coming out on the video, but it's smoother on the screen. And so now we've capped our frame rate. So here, cap frame rate at 60 Hertz. Okay, now we just have to make it move in the other directions. So let's do W and S. Oops. So I'm just going to copy those 2 lines and change this to be W, which is up, which means we're going to change Y. And remember, up is negative instead of positive. And now we need to change this one to S, and that's going to be Y plus equal 5. Now let's run that. So there it is. I can move up, I can move down, I can move left and right. But there is a problem. Notice I can move off the screen. It's not keeping me on the screen. It's letting the player leave. And in fact, I can probably go off the screen, and then I'm still moving, and I can come on the side here and surprise you. And I can go up here and over to the top, and I can come on the top. There I am. So if we want to cap this and keep them so they can't leave the screen, so we want it so that they get to the edge like that and it stops them, we need to add the code for that. So let's go ahead and do that really quickly. But you'll notice that the way that we're writing this code is it very closely matches what we said with the how game loops usually go in video games. Import modules, initialize stuff that we need initialized, including the variables that the game's going to use, and make this clock. Now, once we're done with that, we have our game, the middle part of our game loop, the kind of game loop proper, which is going to be doing. Let me move this so you can see all of the program here. Which is getting in or processing input, getting the input, doing something with it. And then we have our render portion, clear the screen, draw the things, update the screen at the bottom, and then that's in a loop, so it'll go back up and do it again. How do we ever get out of it? Well, in our case, only when we press escape. All right, so let's go ahead and contain the player on the screen. Now, how do we do that? Well, we just need to have something here that basically says if they leave the screen. So I'm going to do this down here. I'm going to say if player X ever gets to be less than 0. Now we have 2 options. We can make it wrap around so they go to the other side, Or we could just keep them at 0. So I'm going to just say if it's less than 0, then set player x equal to 0. And we also need to contain player x on the other side, on the right-hand side of the screen. So if player x is ever greater than, in our case, 799, then set them equal to 799. Now we need to do the same thing with y. If player y is ever less than 0, then set them equal to 0. Now we need the other dimension of y on the bottom. So if player y is ever greater than 599, then set player y equal to 599. So this processes input. This is kind of ensuring the player stays on the screen. Let's run that. And there they are. We're running around. And now where they went off the screen before, they're now kind of capped at the edge. All right, so now we have a game screen and a game loop that loaded everything, started the loop. The loop will run until we hit escape, and we can control that with WASD on the screen. And later on, we can make it that you hit like the control key or the shift key or whatever, and it fires, or we can make it so you can move things around with the mouse. If you want to, we can make an enemy that chases us. We can do whatever we want now. Including adding other keys that do other things. All right, now for fun, quickly, because some of you are going to run into this when you write your code. What would happen if we forgot to clear the screen here? Now remember, the screen will remember whatever we drew on it. So if I forget to clear the screen, it'll start off looking normal, but then as I move around, it'll leave this trail behind. So now I've kind of created this like Etch-a-Sketch. All right, let me run it again and try to write out hi. All right, so there we go. And generally, you're going to want to have this clear the screen. But notice that this fits our kind of vision of how a game loop works. Initialize stuff before the loop, inside the loop, read input, process the input, do other calculations we need to do, and then render, which consists of clearing, drawing all the things we need to draw, and then updating the display. And then after the loop, any cleanup stuff. In our case, just close the window and in. Okay, so that's that. Let's switch back to the presentation just for a second here. All right, back to the presentation. We wrote that code. If you're interested, I can post that code to the webpage, or you just follow along and type it in. But that's all we're going to do today. I want you to finish up the previous lab, because the next lab we're going to write is going to be a real game, meaning that it's going to have you moving a character around on the screen with the keyboard and having things that you interact with where you have to have some goal and a score. And so we're going to look at a couple more things next class, and I'm going to give you time to, or give you a new lab. So finish up the ones you're on. Make sure you get those done. And other than that, stay safe, wash your hands, and if you have questions on anything at all, let me know, and I'll be happy to answer them. Send me a text message, send me something on Discord, but otherwise, one final thing before I say sign off here. Don't be afraid to just play. One of the best ways to learn programming is to just have fun with it and play with it. So for example, make that program that we just did there. Well, I enjoyed writing that and playing Etch-a-Sketch with it. Make that an Etch-a-Sketch program like that, and make it so you can, I don't know, like you want to change the color, or you want to make it so in that Etch-a-Sketch program you have two different colors that you control, one with WASD and one with IJKL, or one with the arrow keys. Have fun with it. Make it a two-player game where you like tag, where one of them chases the other one, and play it with your friends. So whatever you want to do. But don't be afraid to try things that aren't part of the labs for the class, because really that's where you learn programming, is just having fun with it. And for me, I've said this before and I'll say it again, that programming is really, for me, magical, because it lets you take ideas out of your head and put them in the computer, and the computer now is running ideas that were in your head and doing things based on them. And the other cool thing about programming, I think, is that it's kind of like the ultimate creative tool, that you can write a program that does stuff and draws things and makes whole other worlds come to life, and you can transport yourself into those worlds, and it could be something simple like that Etch-a-Sketch thing, or it could be something complex like a whole VR thing where you put on the headset, it looks like you're under the ocean, and there's a whale looking at you, and there's jellyfish swimming all around. And programming allows you to unlock the magic of all of that stuff in a way that no other kind of creative media allows you to do. Well, maybe like writing a novel or a book or creating a movie, but those are a little more passive, that they require somebody to read them and interpret them and get the story out, where a game can change the story based on what you do. And programs are kind of the gateway to do that. So I would encourage you to play, have fun, try things that I'm not even suggesting trying, but make sure you do the labs. If you do get into that habit of playing with the stuff and enjoying it, then the labs will be relatively easy. Again, if you get stuck or you're having problems, let me know. I'm always here to help you. And if you need me to, I can come down to the lab or come down to my office, and we can sit down together and I can help you with whatever you're stuck on. All right, that's it. I'm signing off now. I'm going to stop. I promise.